Maybe wait 1 more minute. I don't know, like the name, I can't remember. I've tried. Probably no. I've tried it like when I was in like restaurants and stuff. So like I never, because like it was a gift, so like I never opened it. It's just like. So I couldn't find mooncakes here, but I have some chocolates. So celebrating the Mid-Autumn Festival. Just take as much as you want. Dude, like you have like a sense of chocolate, like that's right. Even through your mouth, all right, that chocolate is okay, so today we start talking about machine learning at Spark, and we go to the good parts of the course because I think most of you might remember something about Python, and we go to some cloud-based computation. So you won't be stuck in installing some basically infrastructure for your project. So having said that, today you learn how to do most of your project. Still, if you're in groups of 3, you still need to have another platform. Maybe you run on your local machine, and or AWS, or just keep it there. Just maybe once people maybe they want more. So yeah, so if you're in a group of 3, on top of what you learned this class, you need to pick another platform. It could be AWS, could be Google, or your local machine. All of them are fine. So, but I strongly recommend to learn how to do in the local machine, because you might end up like Shashank, you might end up doing something in Spark. So knowing some infrastructure really helps you. So any question from previous classes? Let's see if most of you are over Zoom today. So let's see if somebody has questions. Okay, so let's review some basic concepts, and then we go to hands-on experiences. So you might heard of artificial intelligence. It's basically learning some patterns from your data, which is machine learning is a big part of artificial intelligence. And also, you might heard of statistical learning. It's just basically a framework or a subset of machine learning, which you basically find patterns through statistical models. Also, we have some algorithms like linear regression, which is the statistical learning, neural network, SVM, deep learning methods, and etc. So linear regression might look the easiest one, but actually, if you look at the proof of linear regression, it's actually, I think, is the most complicated one. So I used to teach a statistical course, and in that course, I provide some proof for y equal a times x plus b, and it was really complicated. Yeah. So, however, neural network, SVM, deep learning, they might sound complicated, but actually, usually there is no mathematical proof, and you just you just find the pattern by try and error, and some optimization methods might be included. This term, machine learning, was coined 1959 by Arthur Samuel. Basically, learning by computer without that much of intervention. So you provide some general rules, and your algorithms try to learn something from the data. So I think some of you are not muted. Please mute your mic. Okay. So just as a small example, let's look at the Titanic problem. So in Titanic, you have something about gender, ticket class, I think number of siblings. Some of them doesn't make sense. And maybe, ticket price, age, gender. So these are some data, and you provide the general rules of, let's say, maybe logistic regression, and the model figure out, or the computer figure out, what input could lead to some certain outputs. But in other types of programming, or generally in programming, you should provide all the steps, like see this, do that, do this. So, but in machine learning, you provide the rules, and your computer finds the pattern. So generally, we have three general types of learning: supervised, unsupervised, and reinforcement. In supervised, the data is labeled, which means we have a target variable, like for Titanic, somebody survived or didn't survive. In unsupervised, you don't have a target variable, and you try to classify your observations based on the similarity. And in reinforcement learning, your algorithms try to find the patterns or some solution by looking at the previous outcomes. So here I put the summary of machine learning algorithms. For example, I think most of your projects are most likely you either on continuous unsupervised, let's say doing k-means, PCA, or based on my previous semester experiences, maybe supervised and categoricals like KNN, trees, logistic regression. And I'm pretty sure you already have some experience with linear regression, which is under supervised and continuous, supervised algorithms and continuous target variables. So your columns are type of machine learning algorithms, and your rows is basically if your target variable is continuous or categorical. Yeah, these, three types of machine learning is the most, basically in last 2 semesters, it was the most of your projects. So classification, regression, or clustering. If you want to do other things, especially reinforcement learning is really cool. If you do something reinforcement learning, I give you a little good bonus. That could be a complicated project. However, I'm pretty sure your previous Python courses, classification, regression, clustering should be very straightforward for you. Just again, as a recap, so this figure explains good differences between supervised and unsupervised. On the left side, which is left side, do you think is a classification problem or regression problem? Yeah, it's obvious, yeah. We try to find a border that classify our observation into groups. In the right side, you see clustering. So you group your data based on their similarities, and the observation would be in certain clusters. Okay. This is the general concept of regression. So here you see a 2D problem. So you just have one X and one Y. And we try to find a line that summarizes relationship between X and Y. It doesn't show the whole relationship. As you see between the green dots or green rectangles and the line, there is some distances, just show you the offset or error. But that line simplifies the relationship between X and your Y. So if you have more X up to 3D, you can imagine, but more than that, it's hard for human to imagine it. But anyway, if you use a linear regression, regression trees, SVR, so-called vector for regression, all of them At the end, you try to find a line that simplifies or summarizes relationship between your inputs and outputs. I'm pretty sure you had some experience with the logistic regression. So logistic regression is basically a continuous, the outcome is continuous, but as you see, it's limited between 0 and 1. And the output of this regression, if you just convert it to P could be the probability. So let's say for, again, Titanic problem. So if you use logistic regression, the outcome of model could be like P could be 0.5, 0.6, 0.4. So if P, which you could refer to probability, is more than, if usually more than 0.5, we consider as upper class or 1. If it's less than 0.5, we consider as a lower class or 0. So in that way, your model, you have a model that has just one output. The output is probability or P. And based on your threshold, you consider if it belongs to which category of your data. And similar to other models, like let's say you use decision trees for regression or SVR or neural network. In all of them, you have a P, which probability of belonging to which group, and you have some certain thresholds. If it's more than or less than that threshold, you would decide it belongs to which category. And you might remember you had AUC concept. So in AUC, you change the threshold and you make the line and you find the ADA under the line. But usually, if just two class classification, our threshold usually is 0.5. More than that, upper class, lower. Lower than 0.5 belongs to lower class. Okay. Neural network. It could sound complicated, but it's nothing. Just it's just a matrix computation or multiplication. So you convert your input to some basically, and you can consider as the input layer. You multiply to some you multiply to some numbers or the weight of the links, and at the end you basically end up being in the output layer. So depends on the value of your output level, you can decide it belongs to which group. I don't want to go to that much concept because it's out of the content, but I just skim through them for you to just memorize, to just remember those concepts. SCM also is one of the most applicable classification algorithms. So it just tries to find a border that maximizes differences between your classes. K-means. So you find basically you find some centers, center of the clusters that I don't want to go to details that much, but anyway, so let's say you want to divide your data into class. You just pick 3 random centers and you try to find the best centers through some repetitions until the distance of each node to those centers would be minimized. You just need to know some general idea about these algorithms, and nobody asks you how to prove it. Just knowing that what would be the final outcome could be enough for you guys. Any questions so far? It might be a little boring for you because I'm pretty sure you already have. I'm just asking through that. So have you ever coded something and that requires deep learning? So in no classes, right? What about neural network? Have you had experiences of using neural network? Now I'm just asking, in one, have you had any classes that they? No? What about Python analytical programming? Have you had neural network in that class?
The farthest that we've gotten is for machine learning classes like SVM and stuff like that. Yeah.
I mean, it was just the basic overview.
So have you like had a Python code that used like k-means or neural network?
Oh,
The institute.
yeah.
K-means,
yes.
No,
On supervised learning, we learned about k-means and
and random forest.
yeah.
So, but these are, but you use them for classification, right? Okay, so I mean, no worries. I mean, at the end, almost all of them are the same. So, if some of you are in my business intelligence class, so at the end they are just modules. So, or if you never had that course, just consider some packages that, okay, one time you use SVM, random forest, and the time you just import a package for neural network. So that's it. Okay, so if I want to super simplify deep learning, it's exactly like neural network, but you have more hidden layers. So having more hidden layers lets you to find more complicated patterns in your data. One of the most complicated patterns is image processing. So you might have multiple hidden layers. One layer is focusing on eyes, another layer focuses on the hair type, another one jaw or ears. So each layer might focus on some certain features. So again, neural network is this. Deep neural network, you have more hidden layers. Okay, like this one. Oh, look at this example. So I'm not exactly sure what this deep neural network does, but as you see, we have 3 hidden layers. The first layer is just focusing on the the face edges. Second hidden layer is just focusing on corners and contours. The third hidden layer may be focusing on eyes, ears, and just body parts. And the output layer has 3 classes of animal, person, or car, similar to probabilistic outcome of logistic regression. In the output layer, your models look at the probability of being animal, person, or car. Maybe one of them is 60, another one 20, another one 20. So let's say 60 is for person. So it would say 60%, I'm sure it's for a person. And you might have threshold of 0.5. So you would say, okay, this is a person.
Yeah, exactly. Like she explained this, like they just like look to find like different dog breeds or something to like let the computer tell me like what kind of dog it is. It's just like they built the system with like a lot of different pictures of dogs, and when they upload this picture, find out like what kind of dog the computer will build all the pictures and show you how so this dog.
Exactly. Yeah, you're very right. So like Titanic, you know. So by the way, do you have the Titanic? Have you seen the Titanic dataset before? You had some project, I guess. Okay, so I'm not talking fuzzy things. So yeah, in Titanic, you have a train set. So you, instead of introducing multiple pictures, you introduce multiple records. And your algorithms would learn which inputs would lead to some death or survival. So when you introduce after developing your model, when you introduce new data, it would decide if somebody die or survive. Similar for image processing, you introduce many images, and from those images, it's let's say it focuses maybe on the object parts, corners, and edges, and based on that, it could decide is it animal, car, or pest. Almost similar concepts, but different algorithms. So we have 2 major neural network algorithms. One of them is convolutional. is mostly works on the images. And as you see, we have filters. So I think it gets too much technical. I don't want to go that much in depth. So basically, each filter just means a coefficient. So you just multiply your image on some certain coefficients, and it would be like one layer. Second layer, you make some matrix. So those filters are nothing, just a matrix. And you just multiply it through your image, and then you classify it belongs to which group. First, all of those matrices, oh my God. I have some Invisalign, so speaking gets harder for me and mask on, so. Matrices, okay. So all of them has random weights. So, but what does neural network do? So it just goes through all of those weights and try to find the weight that lead to right classification. And it uses some optimization algorithm to just change those weights to find the best combination of weights that let you to find true classification of your image. Some companies like Google, they made their own version of convolutional neural network based on different filters and steps that they include. But general concept is just you have deep neural network that's maybe trained on some specific types of that. TensorFlow. Have you ever worked with the TensorFlow? It's the most famous Python package for deep learning. So here somebody visualized working with TensorFlow. So let's just go to this link. Just copy the. Okay, so here I have two inputs, x1, x2, one hidden layer. Here's a 2, but maybe they assume there's one over there. So, and outcome. So, and this model tries to classify my dots. So I have two groups of dots, blue and orange. So let's just run it. And first the weights are totally random. And as you see, it's trying to optimize those weights. So you can, almost the classification is 100%. So let's say if I add more hidden layer, and run it. You can do the experiment by yourself. So I give you like some minutes to do that. So you can change the inputs, for example, x1 to multiplication of them. So I give you a few minutes to try. So as you see, I mean, any deep neural network, you just have multiple hidden layers, and your algorithm tries to find the best weights of links so it can classify correctly. Here, I mean, it was like 100% accuracy. So let me increase the noises. Maybe my noise is too low. So on the left side, noise is 0. So let me just increase it. Now dots are mixed much more together. Maybe let me just increase. So now it's a much more difficult problem. So as you see here, the accuracy is not 100% yet because the dots are mixed so bad. I'm running to see if maybe just let's make it more complicated here. So here, as you say, increased noises so bad. So again, I have a 3 hidden layer deep neural network, but still it missed some of the dots because there's such a complicated problem. I have too much of noises. So again, the goal of implementing machine learning is not 100%. If your accuracy is 100%, that's really great. But like here, maybe it's too difficult to reach that certain accuracy. Okay, any questions so far? It's just for having some fun with deep neural network. Yeah, it's a kind of simulation. But as you see here, when I increased my noise to 45, some of the blue dots in the orange region, some of the orange dots in the blue region, because it's too much difficult, even with such a complicated deep neural network, still it misses some of the points. But don't be scared about deep neural network or neural network, everything. And then just similar even to logistic regression, linear regression, or SVM that you have experienced, you just import the package and you identify inputs and outputs. Actually, one of your friends, oh my God, what was his friend? His name. Let me just go over my LinkedIn. I think he did a startup. He made his own startup, and he's right now doing something about artificial intelligence, deep neural networks. So let me find his name. I had him through LinkedIn. I cannot find his name. Maybe I have too many messages. Yeah, actually, one of our graduates. Oh, Gurpreet Singh. Yeah. Do you see the picture background? He has something. He actually, okay. He's the founder of Amphibio USA. So it's his company. So one of your our previous graduate student just made a startup of using deep neural network and deep learning for making amphibious cars. So his cars can go under the water and kind of some like underwater tourism. So yeah. Yeah. So I mean, I'm not sure in which level is his startup, but it's just using, artificial intelligence for underwater tourism, something like that. I think he's in somewhere. He's in Chicago right now. I mean, if you can make money with that, why not? It's for public transit to go under the water. Yeah, I'm not sure which level he is, but I mean, if you have good ideas and you can get money or make business, why not? Maybe make your own startup. Okay, so usually we use convolutional neural network for image and video processing, and some natural language processing or text mining. These are the most common application of it. Other type of neural networks or deep neural networks are recurrent neural networks. I don't go that much in details. Okay, so the applications for like stock market or something related to time series or sequential predictions, speech processing, supply chain forecasting, so on and so forth. So who had or has right now has my business intelligence course? Yeah, or already had. Already. So you remember it was like 9. Do you remember we had the 9 software that you drag and drop some modules, and I told you that you don't have to make everything from scratch. Maybe you go to other people's notebooks or 9 workflows and you find how they did. Maybe based on your specific project, you need to add some components. So similarly for deep neural network or this project in this course, we are doing it in Python. So maybe you can find some notebooks that were developed even for image processing. So based on your certain project, maybe you change the notebooks, maybe you add some components and just maybe, or maybe drop some components. So you don't have to make everything from scratch. If you do that, that's actually good. But I know there's a learning curve associated. So again, for this project, you can look over other people's notebooks, adopt them, and based on your need, maybe you need to change some parts. Okay, so in previous classes, especially last 2 weeks, many of you suffered from using like VirtualBox and local installation. I think local installation, at then it would be, most of you would be able to do that because it's under your control, but VirtualBox and like Horton Sandbox is under a private company. So from now, we adopt or we use Databricks Clouds for Spark. So we use a community version. So what does community version means? There is some other people around the world that they contribute in the development of that platform. And there is a paid version which other companies can use. You hope access under some, or access on the Databricks Cloud, so you don't suffer from hardware installation. But actually, if you suffer, that's good because you learn. I mean, that's a good practice. So let's look at this link, sparkapache.org docs latest ML guide. If I go to their website, so first of all, it has two components. The first component is MLlib main guide, and second one, RDD API guide. Actually, RDD is the older version of Spark and Hadoop environment. People used to work on different types of data structure, which is RDD, which is getting obsolete. So recently, everybody used MLlib and data frames. So because for humans, I mean, you can process data frames types of data much easier than RDDs. Still, if you end up working in a company that they use the older version, maybe you need to learn something about RDD-based data processing. If you have time, I cover some of it, but it's getting obsolete as most of people just use MLlib for data frames. And the advantages for human processing data frames and, I mean, thinking about that is much easier, and developing codes on data frames are much easier. But this is your reference. So you can learn how to do basic statistics. As you see, it has a 3 versions of Scala, Java, and Python. If you look at them, it sounds similar to what you already had. So you define some list dictionaries. It used to cover R2, but I'm not sure, maybe they do not cover anymore, but it used to have some R codes too, but I don't see anymore. So Scala, Java, and Python. So if you're stuck in your project, for example, here, there's the module for classification and regression. You can see they have logistic regression, decision tree, random forest, scatter boosting, linear support vector, and other algorithms. So, for this part, they have R. Okay, so for data management, there is no R. For classification and regression, there is R. So if you're R friendly, as you see, it's pretty much similar to R, so, or Python. So you can just copy and paste for your project, but don't exactly copy paste. Maybe for your project, you need to change some parts. But this is your reference for your project. Depends on your project. Maybe you need to do some certain study by yourself. For example, similar to your previous project, I want to see you guys try to improve the predictive performance. Maybe one way is doing feature selection, another way trying different algorithms. Maybe you do decision tree, your prediction is bad. Maybe you do SVM bad, but neural network is good. So I want in your notebook, I want to see you try different ways of improving your predictive performance. So for sure, I don't have time to cover like all those algorithms and methods that you see here, but depends on your project. Maybe you pick 2 or 3 of them and you show me you try to improve. Similar to that game that I showed you, I'm not sure if it's still there. So maybe based on your data, you never can get like 90 something percentage. That's okay. But at least I want to see you guys try different approaches for improving your performance. And I think Python, both of them are fine. I don't know Scala and Java, but if you know and you want to use the project, you're more than welcome. At least I can learn from you guys. But I think either Python or should be fine for your final project. Even for local installation, you can just Google how to install Spark R, and you can, for your local system, you can still run Spark R and have it as your final project. Any questions? Okay. Let me wait 1 minute for your friends over Zoom, so they might have some questions. If there is no, then I go to the next section. So people over Zoom, can you see my like computer or system?
Yes.
Okay, okay. Because I don't see the Zoom bar in my system. I was not sure if you can see it or not. Is there anyone in this class, I mean, right now that are in group of 3? You guys? Yeah. Yeah. So you guys, I think it's very good to try 2 different platforms. Most likely I have time to teach Amazon AWS, and Databricks is the most of my teaching through Databricks. Is founded by the creator of Spark, so they implemented Spark very smoothly. Maybe you can do virtual but local installation. I think if you do Databricks and AWS or local installation, all of them are fine, but just pick 2 of them. But VirtualBox, I don't recommend. It might face you might face some errors. Okay, so from today, I mean, most of my teaching would be through Databricks Cloud. If I have time, I still go back to some local installation, and most likely I have time to teach you Amazon AWS, but most of our teaching is through community version of Databricks. What I mean community version is a version that is maintained by the community of programmers, and also they don't have too much nodes. So you just have 1 node for just learning how to do Spark coding, I mean, Spark PySpark coding. So just copy this link on your browser. So for me, I already created the account, but if it's your first time, go to sign up and just put your information and get it started for free. So the community version is free. I'll give you a few minutes to do that. So let's say 4 minutes. Yeah. So let me see, maybe they change a little. You should pick up community version. Yeah, just pick community edition. So you look, if you don't pick any specific platform like AWS, and after you create an account, you get to community edition, that's here. Let's wait like 2 more minutes. So. When is the Indian party? It was the color party. Was I forgot the name? There's like Indian party. They throw some colors. On March. Oh, okay. Next semester. So what the name was Bali or Holi? Holi. Okay. Yeah. So. Until you're making the account, let me check the startup, see which level is it. Oh, they have some opening for internship. So if you look for some internship, it's research assistant, chemical. Maybe you go to under AI. Almost they hire all types of engineering. So yeah, do you guys have you seen Gurpreet? Gurpreet? Yeah, you remember him, yeah. Oh. Okay, so if you already created the account, just sign in. Okay, so similar to the local version of Hadoop and Spark, or I mean, you need to initiate a Hadoop and Yarn for just one node because it's a free version. And on top of that, you can run your Spark codes. So first step, we need to initiate a cluster. So what they mean cluster just means isolated Hadoop file system, which has Yarn already set it up on top of it. So on the left side, go to create. So when you click on create, go to cluster. But it's a cluster, but just remember, they just mean Hadoop and Yarn merged and integrated to each other. So just put the name. I put name of sample. And just press create. That's it. Just leave it as it is. So it might take like a few minutes to create. So if you go to compute section on the left side, so you see it's loading, right? So it
no, excuse me.
Yes.
Did you share the screen of the program?
Yeah, I think there's an issue. So
it's right now I can only see the web page.
Okay. I think there's. I got the Zoom. Okay, let me close Zoom and I get back. Okay, it seems my Zoom is freeze. So let me just close. Oh, what happened? It doesn't close. Okay, I got to something. Okay, you guys over Zoom, do you see my, I'm on the, like a page, Databrickscom?
Oh, yes.
Okay, that's good, that's good. Sorry, it was freeze for like random reasons. So, okay, first time you log into website, data. So have you seen how I logged in? Hello? Okay, so let me log out to be sure. So I log out for now. Okay. After you create the account, so again, you can copy this one, paste here. You lead to this page, then sign in. I'm not sure if they can see it. Hopefully they see. Okay, so on the left side, click on create, click on cluster, and just pick a name, random name, maybe sample. So since I already created, I don't see any create cluster button here, but after put the name, just click on the create cluster and leave everything as default. It might take a few minutes to be created. So again, in the create, press cluster, pick a name, and on top here, just press create cluster, which is deactivated for me now. Maybe if I go here, let me just close it for now. Okay, I do it again because of your friends couldn't see what I was doing. So this is the first page that you see in Databricks. On the left side, go to the create and then choose cluster. Here, just pick a random name. I pick sample. And then press create cluster. Again, if you go to the left side, if almost in the middle of page, you see a compute button, press on it. As you see next to sample, which is my cluster name, the system is loading. So until you're loading, just Google movie lens dataset 100K. Movie lens dataset 100K. Go to the first link and download ML 100K zip file. You might, for your VirtualBox assignment, maybe you already downloaded and it's on your system. So if you already downloaded, you don't have to do it again. Just just click on ML 100K zip file. So after downloading is finished, just unzip to a location. Okay, I wait like a couple of minutes for all of your friends to be able to download and unzip the file. So you might remember in the local instance of Hadoop, we had a command copy from local, and basically you copied from a local address and copy to a Hadoop folder, right? Here, we just did through drag and drop, so much easier. So hopefully by now, all of you downloaded the movie lens 100K dataset. If you again get back to here, next to my sample, I just see loading sign, but I refresh my page, and it's already loaded. Okay, so on the left side, do you see a data button? When you click on data button, this page will pop up, and it's still loading, but that's okay. But go to create table and select create table. Do you see here it just said drop files to upload or click to browse? So you can drag and drop view the data, or you can just click on this rectangle, this gray rectangle. I find my u.data, which I already unzipped it. Or actually any table, that's fine. But I just pick u.data because I want everybody have same data. So press open and just wait. Hopefully by now all of you will be able to load. So again, here, click on create table with UI. When you click on it, it asks you which cluster you want, which just have one cluster. So my cluster name is Sam. So after uploading, I click on create table. It asks me what is your cluster. Then click on preview table. Go to the button. Just now it tries to load my table. So as you see, my data doesn't have any column name, and also it just guessed the type. You can change the column names. You don't have to do it here. Later over Jupyter Notebook, you can change the column name. But if you're interested, maybe for first one is user ID. I'm not sure if it was movie ID or user ID, but I guess it's second is movie ID. The third column, ratings, yes. So ratings actually makes sense to be string because rating 1 to 5, but later, maybe we want to find the average of ratings. So it's easier here you change the type to integer. So I change it to integer, but you don't have to. I mean, later you might even Python, you can easily change the column type. The last one is the computer format for timestamp. So it's which year, which month, which day, but it's in the numerics. Maybe I just change it to timestamp, but you might remember it's just a computer version of date, which is easier for computer. And my table name is u_2_data because I already loaded to some similar tables. You can change the table name, that's okay. Maybe you can put your name. Or u.data if you want. After that, just press create table. That's okay. Sometimes it gives you error, but it should be fine. I know. So, I think if first time you log in to Databricks, it might give you some random error, but that's fine. So if you, on the left side, if you go to data, just press on data, you should see your table here. Do you see? So that error was fine. So no worries. I mean, we do it through Python. So on the left side, press create. And do you see first one is notebook? Just click on notebook. Just put a random name. I put class. Then press create. Okay, it just asked me, I already had that. So let me just bring it. Just a sample. Data or practice. I think this is already created. Just give me saying that already have that notebook. Okay, so do you see something like Jupyter Notebook? So for example, I type 3 multiplied by 5. Press Shift and Enter together. 15. Or print hello world. Hello world. Also, I put some codes in your last slide. So do you see I import PySpark package? And I mean, nobody's like later teach you. So with SQL context, I'm just defining that I'm going to bring a SQL or just a table. And within that SQL context.sql, do you see I put SQL commands? Select everything from you underline that. If your data, I mean, if you have another name, that's okay. So the file name might be different based on how you rename your table. So let me just copy. Oh, I think I changed it to Hamid. Yes, instead of udata, my folder name was Hamid. So just see what is your the folder name. I mean the table name that you bring. So if it's u underline one underline data, you should put that. If it's for me, it was the name. And I'm pretty sure you know another ways of showing your data. Maybe if I want to limit to 10 rows within the parentheses, I put 10. I just see 10 rows. So looking at this code, there's a lot of similarity with Python. So just here, I introduced the type of data that I have. I am doing a SQL query on my data that I imported. And now data is a data frame. I can use Python-based codes on data frame from now. For example, .show is a method for showing your data frame. From this class, I'm going to cover so much of notebooks. So you learn how to do machine learning, descriptive statistics, and some visualization using PySpark environment. So as you see, I mean, watch the video again. Setting up a cluster here is pretty easy. You just log in, create cluster. Next time, and then you have to upload the data. Then basically you need to create a notebook. Huh? In this platform, almost all of them are already installed. You just need a little bit of installation, but almost 90% of the package is already there. So it's much easier. Okay, so this is the way that most of you do your project. So as you see, it's very straightforward. Just need to review some Python codes, but you don't have to memorize everything. Even in some classes, I recite and review some Python codes, but it's better to have some general ideas about how was your Python class and how was some of the codes. Other than that, you might see I'm using some SQL commands. No worries. Again, you don't have to remember SQL. I just use a little bit of SQL commands, but these are very straightforward commands that almost everyone knows. So you don't have to take a like SQL class. If you already remember some SQL commands or you want to take, you're more than welcome, but it's not necessary for being able to do your project. Any questions? And just today, maybe give a shot to the Databricks platform, just play the different section of it. And generally speaking, after doing your work, it's better to export your data frame. I'm teaching it later, but now I want to show you an important thing. On the left side, go to compute. So this is a free version. If you don't work with your cluster, it would shut down after a while. But it's better to do a practice of shutting down by yourself. For example, here, when I take my mouse in the right side, look, it's just showing termination button. It's better to terminate. So some platforms like AWS, they don't terminate and they charge you. I remember when I was a student, they charged me 1,500 something. But I said, I'm a poor student, please forgive me. And usually they forgive, but I cannot guarantee every time they forgive. And some of your next classes, I'm not sure how many classes, but we do some project on AWS and you have to terminate. Otherwise, they might charge you. Hopefully they forgive, but there is no guarantee for that. You don't want to see like $2,000 like bill on your account. So, but here you don't have to. So if you don't do anything and just leave it as it is, it would shut down automatically or terminate automatically. But I mean, just it's a good price to do it. Any questions from you guys or people over the Zoom? I mean, there's no time cap for it. You can just work. As long as you work with it, that's okay. If you don't work with this one, it would shut down. But it's a totally free version. Okay, that's for today. And thank you very much. Enjoy the rest of